Hey kids, this is Mr. Cozy, and this is video 42, where we talk about transformations. And today we will look at horizontal and vertical shifts, otherwise known as translations. So let's get started. So imagine that you wanted to graph something like f of x is the square root of x minus 2 plus 1. One way that you could graph this is to make a table of x's and y's, choose a list of x values, plug them in, get the matching y values, plot the points, and connect the dots. And this is actually the method that your calculator uses. It chooses x's from across your screen, plugs them in, calculates the matching y value, and then makes a dot and connects all of the dots. I'm going to show you a different way of graphing that's maybe a little bit it's kind of slick. It's kind of slick. I dig it. So let's put this on hold for a second and look at a different example. Let's take a look at f of x equals x squared minus 1. Let's suppose that I want to graph this. Now, the first thing that I want you to notice is this function is a version of the elementary function x squared. If you recall, prior to watching this video, I asked you to complete the worksheet of elementary functions, and one of the functions on that worksheet was x to the second. F of x is x to the second with a little bit of something added on to it at the end. Okay, so I want you to think of this as two parts. This is an elementary function that in this case is x squared, and then there is a transformation applied to the function that will change it in some way, and that's specifically the minus 1. And if I want to graph this, I just simply have to think about each of these things in turn, instead of doing that tedious plugging and chugging. Okay, so let's take a look at a set of axes here. And let's just take a look at the elementary function x squared. X squared has 5 anchor points. They are -2, 4, -1, 1, 0, 0, 1, 1, 2, 4. These are the anchor points of x to the second, and I call these anchor points, or APs, because if I graph these points out and I know something general about the shape of the function, I can come up with a pretty good graph of the function. Okay? Now, let's be clear here. This is x squared. It's just plain old x squared. Okay? So if I want to graph x to the second minus 1, I want to start with these anchor points. And then what I will do is apply whatever transformation transformation I see to these anchor points and plot the new points. And that'll be my graph. So let's talk about this particular transformation. This is what we call a vertical shift. Okay? A vertical shift is a transformation where a number is added outside of an elementary function. Okay? So this -1, I'm just adding -1 outside of x to the second. Okay? Anytime I add something to the end of a function outside of the function, that's a vertical shift. In this previous example here, I have a vertical shift of +1. Okay? This +1 means that the whole function is shifted up 1 unit. In this example, the whole function is shifted down 1 unit. Okay? So what do? In a vertical shift, you add the vertical shift to the y values of your anchor points. So instead of 4, 1, 0, 1, and 4, I'm going to add -1 to each of these y values. Okay. Now, if I plot these new anchor points, what I'm going to get is the graph of f of x, x to the second -1. Okay? So instead of plugging and chugging, choosing x's, plugging them in, and getting y values, I think about anchor points. I think about a set of points that lets me recreate the graph of the function, and then I transform those anchor points. Okay? Let's take a look at another example. Let's take a look at g of x equals absolute value of x plus 2. Okay? Absolute value has anchor points. It has 3 anchor points. -1, 1, 0, 0, 1, 1. This is in a V shape. A V shape. This +2 is a vertical shift. It's moving everything up 2 notches. So I add 2 to all of my y values. And then I just graph these new anchor points. -1, 3, 0, 2, 1, 3. There we go. Oops. It's kind of hard to make straight lines on this thing. There we go. V shape. Okay? If I add something to the outside of a function, that is a vertical shift. A vertical shift. So, let's come back to this example. I have something added on the outside of a function that's a vertical shift. I also have something added to the inside of the function. This is a horizontal shift. So let's take a look at a different example. Let's take a look at the cube root of x plus 3. Okay? A horizontal shift happens when a number is added to the x variable. When it's added directly to the x. So, horizontal shift. Oops. Horizontal shift right here. Okay? So what do you do? Horizontal shifts happen backwards for reasons that I'll explain in class. They happen in reverse, meaning that you should subtract the value of the shift. From the x values of your anchor points. Okay? So here, cube root has 5 anchor points. X is -8, -1, 0, 1, and 8. And then my y's are -2, -1, 0, 1, and 2. There's a +3 added to the x. So because horizontal shifts happen in reverse, I subtract 3 from each of my x values. So this is -11, -4, -3, -2, and 5. Meaning that if I graph this, okay, -11, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 is way out here. It's going to be -11, -2, -4, 1, 2, 3, 4, -1, -3, comma 0, -2, comma 1, and 5, comma 2. Here is the graph of my cube root. Okay, horizontal shifts happen in reverse. Now I know that time is short, but I do want to show you a few more examples. So let's just press on. Let's return to this example now. F of x is square root of x minus 2 plus 1. Okay? What's the elementary function at work here? It is square root. The anchor points for a square root are 0, 0, 1, 1, and 4, comma 2. Okay? Now I have 2 transformations here, but I'm fortunate in that this vertical shift happens to my y values. This horizontal shift happens to my x values. So I can just handle these separately. A +1 on the outside tells me to add 1 to all of my y values. A -2 on the inside, so this is a shift of -2, and I want to subtract -2 from all of my x's. I subtract because horizontal shifts happen backwards. So subtracting -2 is like adding 2 to all of my x's. And these are the points that I plot to graph this out. 2, comma 1, 3, comma 2, 6, comma 3. And there we go. Okay? One more thing, and then I promise I'll stop. If instead of an equation, you have just a picture of a function. Let's say that this is f of x, and you want f of x plus 1 minus 1. Okay? Just look at the picture of the function and choose out some anchor points to work with. So -3, -2, 1, 3, 3, 2. Choose out some anchor points and then transform them using the exact same rules we talked about. I would subtract 1, I would subtract 1 from all of my x's and subtract 1 from all, subtract 1 from all of my x's and subtract 1 from all of my y values. And then graph this out and have it look kind of like this does, yet in a different position on the plane. Okay, I'm way over time. I'm sorry, but there was just a lot to talk about here. We'll stop right here. Have a great day. I'll see you later. Bye.